Alright, I'm going to use this video to explain how we're going to use R program to do non-parametric test. In this video, we are going to look at the ordinal data, and those ordinal data, they cannot meet the assumption of normality, so that's why we must use non-parametric test. Non-parametric tests cannot be easily done using Excel, therefore we must use R to do so. Before we use R to perform non-parametric test, want to stress what is ordinal data. Firstly, ordinal data, they are ordered categorical variable, and it is different from unordered categorical variable. So you can use some examples to better understand what unordered categorical variables are, such as your birth country, your first name, birth month, or this. So it's your unordered category variable. Ordinal data is also different from interval variable. Interval variable must have the same equal distance between each point, but for ordinal data, we do not require that. Okay, now I'm going to use the lecture notes. There is one example on drug A and B. How do these two drugs affect the urine promotion? If you look at your slides, so you will notice in this example, we are looking at the if there is difference between drug A and B in promoting urine formation. So this is a two-tail test, all right? And if you examine the table, you'll notice we have 8 patients for drug A, 8 patients for drug B. So the sample size is relatively small and normality is very hard to achieve. Therefore, we are doing the non-parametric test. So in this case, is your Wilcox rank sum test. Now, let's look at the R. All right, I have opened the data that require for us to do the non-parametric test. So the data name is MWU, which has already uploaded to LMS. So if you open the MWU data file, it's in a CSV extension, all right? So if you open this file, you can see there are 3 columns. Patient ID, which we actually do not pay much attention to, right? So you have 16 patients in total, and you have urine, which is your response variable, and you have your independent variable as drug. So you can see AB, right? So urine is response variable, drug is independent variable. Now I can just go to the R program. I'm going to set a file name the same as just now the CSV file, MWU, right? So I'll just key MWU equal read CSV, right? I'm using this command to open this CSV file, and then I'm using the file choose bracket for us to look for this exact file, right? Okay, so I'm going to execute this command. So it will bring me to the folder where I have saved my MWU. So I'm going to open it. So the file is already there. I can go ahead look at my data file, so I can see I use head MWU. Right, so I use this command, so it will show me, okay, this is my right file, so I can just use it to perform my non-parametric test. If you take a look at your if we look at our Word document, right, so the command for us to perform Wilcox test is simply wilcox.test. Then inside the bracket, you are going to indicate your response variable, the wave sign to separate the response from the independent variable, right? Data, as we have already given the name, equal to MW. And this text is to tell the Wilcox test we are doing two-sided test, right? So we can just simply copy the whole string of text and let's just copy it into our R, right? Just take note, when you copy from your notes, you probably will end up having two arrows, okay? So you must remove one, otherwise R will say there is error. Okay, now we can just simply click enter. The only thing you need to pay attention to is the p-value. Okay, so all these warning message or the W values are not very important to us. So we just need to focus on the p-value. So in this case, our p-value is larger than 0.025 since we are performing a two-tail test. So we are comparing this with 0.025. So in this case, we have to say we fail to reject null hypothesis, and we have insufficient evidence to accept the alternative. That means drug A and drug B has no difference in promoting urine formation. Okay, so this is a way for you to perform Wilcox test. That's by importing the data, MW. Alternatively, since the data size is manageable, we can actually key in the data and then do the Wilcox test. So if you look at the Word document, we can simply key drug A. Okay, so let me just copy this drug A. Okay, we say this is a 1000, 1180, 1005, 1930, all this. So I'm just going to copy to R. Okay, so that's for the drug A. Okay, similarly, I'm going to just copy drug B. All right, just double check there isn't any additional arrow there, huh? Enter. All right, so now we can perform the same Wilcox test. So you can, okay, let me just copy from the Word document, it's easier. So just use the Wilcox test, drug A, drug B, alternative. So as I say, we are doing the two-sided test. So you can just copy that down. Okay, just pay attention. There is a, just to take note, there is a additional arrow you must clear. And then just go to the end of this command. Enter. All right. Eventually, you are going to get the same p-value and the conclusion will be the same. All right. So we are just providing you two different ways to perform the Wilcox test. Okay. The second example we are going to do is for the Wilcoxon sign rank test. This sign rank test is for the ordinal data that are paired, right? So unlike just now the rank sum test, okay, so those are more analogous to your two independent t-tests. Sun rank is similar to your paired t-test or dependent t-test, all right? The command in R is very similar, right? The only difference is that you are going to give a paired at the end. So you just write down paired equal to T, capitalized T, huh? Or you can just give the full name as TRUE, true. Okay, so let's look at the example. We are going to perform the sign rank test. So in this case, you have 10 patients, all right? So they have been given, they have been measured for their pain scale, right? So before administration of drug C and after administration of drug C, right? So how we're going to do this in R? Okay, very simply, right? we are going to, because this is a manageable sample size, 10 each, and also it's in single digits, we can simply just copy all the values into R. Okay, we give a name as a B4C. Okay, B4C. All right, so I'm just going to copy this to R. All right, just take note, there is an additional arrow you must clear. And then, okay, so that's a pin scale for before drug C. And then we are going to copy the second one is after C, so AFC. And then paste it. Okay, just clear the additional arrow there. Go to the end of the string of text. All right, so that's the variable, okay, for the pin scale before giving C and after giving C. Now we can just copy the Wilcox test. Okay, so we just need to pay attention. We are going to give a paired equal to T. Clear the arrow. Okay, and then once the test is done, just pay attention to the p-value, right? Okay, so if you read the generate output, we just want students to pay attention to the p-value. Apparently, for this dependent t-test, we are looking at whether there are differences before the drug C and after the drug C. We are doing the two-tiered test. So we are still looking at whether the p-value is larger than 0.025 or is lesser than 0.025. So in this case, it's definitely larger than 0.025. So we need to conclude that we fail to reject the null hypothesis. Okay, so there isn't any pin difference before giving the drug C and after giving drug C. There is no pin difference. Okay, to summarize what we have gone through in this simple lab 10, we just want to say that for this lab 10, we only use Wilcox Test command in R. We have shown students how to import data, or you can also choose to key in the values since the sample size is quite small. Wilcox.test, this command applies to both scenario. Okay, so you can use it for rank sum test or for the signed rank test. And the rank sum is equivalent to two sample independent test, while the later one is equivalent to dependent sample t-test.